welcome back to another machine learning tutorial. Today we are diving into a customer segmentation clustering algorithms. Using algorithms like KMeans, DBSCAN, and Gaussian mixture model. And as I continue for this tutorial, for this playlist, I will just go to this. Yeah, so today we were focusing on this customer segmentation. So we will working with real, let's say, transaction data from online retail store. So I have download this data here. It has many many rows. It's almost 500,000 rows. And of course, I couldn't work with this because my notebook is not that powerful. And by end of this video, we will know how to group customer based on their behavior using unsupervised learning techniques. So whether you are a beginner or experience experiment expert, sorry, and this video has something for you. Let's get started. So in this notebook here, we will use unsupervised learning to segment customers based on three key features: purchase frequency, spending amount of money, and product preferences. We will walk through data loading and preprocessing, feature scaling, dimensionality, applying clustering algorithms, evaluating model performance using C-load score, and many others matrices. So let's begin with the importing of the libraries, and I think you are already familiar with such importing stuff. So, but let me just focus on this here. As you can see, the I can import the cluster key means and DBSCAN from the scikit-learn packages, and also Gaussian distribution is here. And for the matrices for the clustering, you can import this from matrices from here. And this we will try to evaluate each algorithm with these three methods. So let's start from the beginning. Let me just import the data. And for the data loading, I will try to load this data, which is, of course, it's downloaded from the Kaggle. I will give you also the link in the description so you can download it because it's a huge data, so I can't load it to my repo. And by the way, I have already explained key means in a more details with really simple examples, so you can have a look in my playlist. So I will just read the data, and you can see how much time it will take just for reading the data. It's really heavy. And of course, you can let's see, for instance, you can write a C or C++ code to read these files, and it will be on fly. So using C++ or C. And you can see now it's and after this I will try to select sub data, because as I said in the beginning, my notebook is not able to do this. It will take much time, and it will finally hanging, and I can't move the mouse. So what I have done here, I just select sub data by country, and because you can see the data here, it has several, it's nine, four, five, let's see, attributes. But for this, I have just selected 300 from the United Kingdom and 300 from the France, and etc. So this for me, let's see, it has, let's see, it's 1 minute just loading the data. And let me just select this. And for now, you can see I have just selected 300 columns from this data, and let me just see what's the the size, data dot size. It's 6,000 column rows, so which is not bad, I will see. And for the data pre-processing, we will drop the non-negative, uh, the non uh, the null values from with these columns here, and for the quantity I need to convert it to integer, and it might be, let's see, the quantity. You can see it's of course it's integer, but sometimes it has maybe this string character also, so we have to convert it to integer. And for the encoding, we need to because the country is a categorical, so we need to make it to convert it to encode it to a numerical features. So we can work with this using algorithm. And here we also need to standardize the data. So you can see, let me just show you the data after the standardization. The standardization, it's try to make the data between 0 and 1. So let's see, dot head. Okay, it's sorry, it's an array now. Okay, it's converted to an array, so NumPy array. But let's have a look. So you can see this is converted between 0, I mean -1 and 1. This is called standardization, and I have also done one video on this. What is the normalization and what is the difference between normalization and standardization? And please have a look on this. And for the clustering algorithms, I'm using KMeans, DBSCAN, and Gaussian mixture model. And here I have for the key means the disadvantage, you mean, let's see disadvantage. It's the number of cluster we have to identify for the and also for the Gaussian distribution. But let's see, we assume this we have only 5 clusters, and for the evaluation for evaluating the cluster, we have 3 models, and you can see here salute score is ranging from -1 to 1, and a value close to 1 indicate well-defined cluster. So it's calculate it's measuring the buoyance inside the cluster and see if the data is assigned correctly or not. And also this is not fixed, there is no range fixed range, but it has to be let's see a positive. And this one hand from 0 to infinity and lower value, it's indicating a good quality. And let's do it. So with the whole data, last time I have just tried with the whole data and it won't work with the big data. And you can see key means it's zero point 0.5, and we have seen that close to 1 is indicating it's a well-defined cluster. And if we see here the key the this method for the DB scan, you can see it's zero point 0.2, and here is minus zero point 0.2. So the minus, it means it's randomly assigned to this cluster. The point is assigned to this cluster, which is let's say a bad let's say clustering result. So with this techniques, with this matrices, we have said that the key means it's performing well on this data in this data set. Okay, so I think this is enough for this tutorial, and if you like this, please subscribe to my channel. If you have any question, of course, drop it down in the comment below, and thanks for watching.